Good day once again and welcome to our general mathematics. In this video, you will be learning the second lesson, which is about rational functions. We already learned some types of functions, or a few of them, like the piecewise functions. We learned a lot about piecewise functions and how to graph it, how to find its equations, okay, as well as the basic concepts of linear equation, the quadratic equation, how to graph it, and the constant and minimum. Okay, so this time this is rational functions, and again, rational functions is just like a fraction. It has numerator and denominator. I know you have backgrounds of this rational function. It is called rational equation in your junior high school. This time it is a function now, and as you all know very well, that a function, a rational function, it has numerator and denominator as long as this numerator and denominator is a polynomial function. When you say polynomial function, it should not be equal to 0. If it is equal to 0, it is not a rational function, neither a function itself, because a function should be a polynomial function. And examples of polynomial functions can be a number, a variable like x, trinomial, binomial, or any equation as long as it is not equal to 0. Especially the denominator. The domain of f of x is the set of all values of x where q of x, which is the denominator, is not equal to 0. This is the thing that you need to be mindful of when you are looking at a rational function. For example, you have rational function x plus 1 over 1 minus 1. Do you think that is a rational function or not? That is not a rational function because the denominator is 1 minus 1. Though at first sight you might think it is a rational function because you cannot see 0, but when you solve for it, 1 minus 1 is equal to 0, which is the denominator. Very important thing in rational function, especially in finding other, let's say, elements of functions or parts of functions like the wholes, like the asymptotes. Later on you will learn that one in this lesson, next lessons for rational functions. So again, just be mindful of the denominator of rational function. It should not be equal to 0, neither the numerator also, of course, or else it will be undefined. Let us straightforwardly learn these lessons by solving the following example. Sorry for the typo error. So let us have example number 1. So you are very much familiar with the real life examples of the functions, right? Rational functions, right? Like the velocity, like the speed, right? The speed is distance over time. You can also have another equations in medical, like the concentration of a drug or a medicine. It is denominator, and many more examples of denominator, especially in physics, as well as in other fields of sciences. So in this example, you have the local barangay received a budget of 100,000 pesos to provide medical checkups for the children in the barangay. The amount is to be allotted equally among all the children in the barangay. So you are now tasked to find or create your own function to budget, the amount that is needed. So y now is equal to the number. Let y be the money to be given to each child. So the value of x here is our domain, right? So the value of the domain is the variable in which the range is dependent on, or dependent sa iyahang domain. So whatever x is being substituted, then it will have another value. In this example, you have budget 100,000 pesos, and you are just going to divide 100,000 pesos to the number of children to be sponsored on the for the medical checkups. So this is now very simple. 100,000 divided by x. For example, there are, okay, you can solve for it. You have the domains, which is the input, okay, domains, input. So you have 10, for example, you have 10. So it is up to you now how to input, or how many, okay, how many, let's say, children in this example, okay. In the exams or in the quizzes, I will be the one to provide the values of x, or sometimes you will be the one to provide the value of x. Okay, so you have this example we are assigning here. For example, there are only 10 children, 10 kids in that barangay. So they are very lucky because they can receive a little bit huge amount of money, like 10,000 pesos. Where did we get the 10,000 pesos? Very simple, 100,000 divided by x, that is 10,000 pesos. 100,000 divided by 20, that is 5,000 pesos, and so on. Okay, very simple, very straightforward. So again, you have these functions, and you have the values of x, which is also our input. It is up to you to, okay, to assign, or to let's say to know, no, or to list the data that you have in that barangay. Okay. That is the purpose of having the function, because once the value of x, our independent variable comes, then we can find the answer. Okay, we can find answer. We are prepared because we have the function, and then the input will just come in. Okay. And okay, another. This is continuation. This is additional. So you have the budget 100,000 pesos. Divide it with the number of children, but a philanthropist wants to supplement the budget allotted for each child. Maybe see, this is Angel Locsin. Philanthropist wants to supplement the budget allotted for each child by providing an additional 750 pesos for each child in the barangay. Okay, so we have additional each child in the barangay, 750 pesos. Okay, so just continue. You have 100,000 over x as our main function. It is added by a philanthropist with 750 pesos. Why did we add it here on the right side? Why can't we just add it also here, 100,000 plus 750 over x? Because this is separate. For example, you have already the, in this example, you have 20 children. 20 children, that is 5,000 pesos. So that those children, which are 20 as population, or their population, will receive 5,000 pesos plus additional 750 pesos each. Because if you add here 100,000 plus 750 pesos divided by x, they will not receive the amount 750 pesos. That will be divided into very small, okay, a small amount. Okay, so that's it. The same process, you have 10. So you have 100,000 divided by x, so 10,000 plus 750, that is 10,750 pesos, and so on. And what if you are asked to graph it? Okay, you are going to graph it. Okay, so if you're going to graph it, later on I will introduce an application, online application for you to graph, because these are big amounts already. You have 10, you have 10,750, you have x, you have y. How can you graph that one? Okay, so that will be, let's say, using functions. Using functions is one. Y is equal to 100,000 over x plus 750. We will learn that one. For now, let us have examples which do not have big numbers or yes, big numbers. So example number 2, this is in the medical. Suppose that C of t is equal to 5t over t squared plus 1 in milligrams per milliliter. Milligrams per milliliters represents the concentration of a drug in a patient's bloodstream, which is ours, t, denoted with t, after the drug was administered. Construct a table of values for C of t for t is equal to 1, 2, 5, 10. Round your answers to 3 decimal places. Use the table to sketch a graph and interpret the results. Okay. Interpret the results. So in this example, you are given the function 5 of t is equal to t squared plus 1. Again, the situation is the concentration of a drug will take effect onto your bloodstream, and it will go directly be administered to the parts of the body which needs healing for that certain drug, for that certain disease or certain sakit. Then this is the concentration formula or function. And you are given the time. You have 0 time, or that less than 1, then 1, 2, 5, and 10 hours. That is per hour. So all you need to do is to substitute 1 here. So 5 times 1 divided by 1 squared plus 1, that is 2.5. Another one, 2. 5 times 2, that is 10 over. Okay, 5 squared, that's 25 plus 1, 26. So you have 10 divided by blah blah blah. So that becomes 2.5. You can use calculator. And the next 5 and so on. So you know how to do it already now. Okay, so you can graph it now. You start from 0, 0. 0, 0 is here. 1, comma 2.5. 1 to the right, x-axis, and then y-axis. So you have 1 and 2.5 is here, and so on. As you can see, this is now the graph of a rational function. It can be like this. Okay, but if you extend it furthermore, it can have another, it can be decreasing, and most of the time rational functions looks like a hyperbola. Looks like that, hyperbola. Opposing parabola. Two parabola can be horizontally, vertically, or diagonally hyperbola. Later on, you will know more examples for that. Speaking of more examples, let us have more examples. Okay, so you have concentration of a substance. So again, this is concentration of a substance. Let us understand this very quickly. So again, let us read the problem. Concentration refers to the amount of substance per defined space. It is the ratio of solute in solution to either solvent or total solution. So you have here, this is a solution. You have also the sugar as the solute, the one that is sediment, Moted Bloom. This one is the solvent, you know it very well. This is your lesson in grade 7. So in science. So solute and solvent, or even elementary now. So solute and solvent, we are asked of the concentration. How can it be mixed? Colloid, it can be a colloid or what? Okay, concentration of a substance. Then there are given values. So concentration is usually expressed in terms of mass per unit volume. Okay, the volume. Suppose that a large mixing tank currently contains 10 liters of water into which 5 kilometers of sugar have been mixed. Again, 10 liters of water in which 5 kilometers of sugar have been mixed. So there is already 10 liters of water in which 5 kilograms of sugar is also there, have been mixed. Okay, a tap, okay, a gripo, will open, pouring 4 liters of water per minute into the tank. At the same time, sugar is also poured into the tank at the rate of 0.25 kilograms per minute. Take note of our units per minute, okay, and our mass is mass per unit volume, kilograms, okay, per minute, okay, 4 liters per minute. So again, you have 10 liters already there with 5 kilograms of sugar. You also have additional 4 liters of solvent or water, and also sugar, no, which is 0.25 kilograms per minute. So they are pouring it per minute. So dugay kaayo di ang pagkuano, let's say pagyabo kay per minute 4 liters. Okay. Okay, so let us define the relationship between quantities involved. We may consider the relationship of the concentration of sugar in the container over the period of time, of course, as the number of water being poured, being filled, also the concentration level of the sugar. Okay, how it is being mixed, okay, being concentrated. So you have independent and dependent variable. This is very useful in your research soon, when you will have your research in grade 12. Dependent and independent variable. When you say dependent, independent variable, let us have another example. Let's say the growth of a plant is dependent on the number or let's say the amount of sunlight received, okay, and the water received. Okay, so that is one. The independent variable is the sun and the water, or are the sun and the water, and the dependent variable is the growth of a plant. Okay, same also here in this example. Okay, we can say that concentration depends. So the concentration is the dependent variable, depends on time for mixing the sugar and water in the container. Concentration, okay. It depends on, our dependent variable is the time for mixing the sugar and the water in the container. Therefore, the independent variable is the domain, refers to the time in minutes. Okay, that is our independent variable, our input, and this input will affect the output, which is the output referring to concentration, kilogram per liter. Okay, so let us represent it using h of x. As you can see, this is another example of rational function. So let us solve for it. So this is our function, first function in the numerator. You have 5 plus 0.25x. This is for sugar. Sugar, our x, our input, our domain, or our, okay, what is our domain again? That is our independent variable, the amount of sugar being poured. Okay, and also the amount of water is another, okay, another independent variable, because there are two, just like the example water and sun. And h of x now is our output, or the range, or the dependent variable. It depends on the input being inputted, being substituted. Okay, so you have 5 and 10. 5 sugar, this is the starting point. Okay, 5 sugar per minute. Okay, 5 kilograms of sugar per minute. 10 liters. Okay, this is already 10. We started, hold on. We started having, okay, this one, solution. This is the solution combination of solvent and solute. We already have 10 liters. We already have 5 kilometers. And we are added 4 liters per minute, 0.25 kilograms per minute also with the sugar. And let us know the function, this one, this is the function. 5, we already have 5 sugar added, okay, added with 0.25 per minute. So x will be the minute. Okay, if you add here 2, they multiplied by 2. 0.25 times 2, that is 0.550, or 0.5. Okay, those are just the same. And also with the water, we already have 10 liters plus 4 liters per minute. Very simple. Substitute just like what we did in the earlier example. 5 started with 0. Use the function, okay, 5 plus 0.25 times 1. So 5 plus 0.25 times 1, that is 5.25, just adding. Next, 5 plus 0.25, you can have this way. This is just the same naman said. 5.25 or 5 plus 0.25 times 2, still you will have 5.5, and so on. The same process with the water. 10 plus 4 times 1, since 1 minute, it is only 1 minute, then you can have that one. And also here, here, and here, you will have the answer here. 5.25 divided by 14, this is the ratio of sugar and then the water. So you'll have 5.25 over 14, or you can simplify it. You'll have 3 over 8. Okay, just the nearest. Okay, the nearest, like this. 5.5 over 18, it becomes 11 or 36, and so on. Okay, and you can. This is what I was talking earlier, that you can use online graphing calculator like the GeoGebra.org/calculator. This lesson is posted on the LMS, so you can click this link and open it in another window. So you use this www.geogebra.org calculator, and you can see this one. You have you have to input here, and it has keyboard here. Kindly click the keyboard on the on the bottommost left side. Here, click, and then you can type in f of x is equal to 5 plus 0.25, and make sure you have the this formula bar. Enter the expression in the formula bar, and then the slash button. Use the slash button to create the fraction. Well, during our next class, I will teach you more how to use this one. Okay, maybe during synchronous discussion. Okay, that's it. That is how you graph. More on graphing, and more examples are given here. Only one example for the rational function. Okay, that's it for this video discussion. 22 minutes. Okay, so this will be our let's say last video for now, and see you next week, okay, on our synchronous class. Thank you so much, and kindly answer the activity below this video. Thank you. Have a great day.